On worksheet U11d question 10, part A. In this question we need to rewrite cos 3x minus 2 sin 3x in the form r cos 3x plus alpha. Start by expanding this bracket using the formulae that are in the formula book to get r cos 3x cos alpha minus r sin 3x sin alpha. We can then compare the left and right hand sides and compare the cos 3x terms with each other and the sin 3x terms with each other. If I compare cos 3x terms, I get 1 is equal to r cos alpha, and if I compare sin 3x terms, I get minus 2 is equal to minus r sin alpha, so that simplifies to 2 equals r sin alpha. Using some trig identities, if I do the second equation divided by the first equation, the r's will cancel, and sin alpha over cos alpha is tan alpha, that's equal to 2 over 1, or 2. And using a calculator, that gives me that alpha is 1.107 to 3 decimal places. The other identity I can use is that r squared sin squared alpha plus r squared cos squared alpha is going to simplify to just r squared, and that's going to be equal to 2 squared plus 1 squared. Generally just would write r squared equals 2 squared plus 1 squared. That means that r squared is equal to 5, so r is equal to root 5. To finish off though, I need to write my question in the form that I've been asked for, 2 sin 3x, so that is equal to root 5 cos 3x plus 1.107. Part B now asks me to find the x-coordinates of where the two equations that we're given meet, where R1 to form the two regions R1, R2. So I need to solve the equation 2 sin 3x plus 2 is equal to cos 3x plus 1. If I move my numerical terms to the left and my trigonometric terms to the right, then I get 1 is equal to cos 3x minus 2 sin 3x. This right hand side is what I had in part A, so I can replace that with my answer to part A of root 5 cos 3x plus 1.107, and that is equal to 1. And I'm going to swap my left and right hand side over when I do this. If I divide by root 5, I'll get cos 3x plus 1.107 is equal to 1 over root 5. And so 3x plus 1.107 is equal to the inverse cos of that. Using my calculator, I need 3 results because there are 3 points that I need to find. First one that the calculator gives is 1.107. Second one is found by doing 2 pi take away 1.107, and that's 5.176. The third one is found by doing 1.107 plus 2 pi, and that is 7.390. If I then take away 1.107 from each of these and divide by 3, I'm going to get solutions for x as 0, 1.36 and 2.09 as required. In part C, I'm asked to integrate my two equations. The integral of sine is negative cos, so the integral of 2 sin 3x is going to be negative 2/3. By the reverse chain rule, I have to times by a third. Cos 3x plus 2x plus constant of integration. In the second part, when I integrate cos 3x, I'm just going to get positive a third sin 3x plus x plus another constant of integration. In part D, I need to find the area of R1. This is the integral of fx take away the integral of gx. I can get the area under the first curve and then take away the area under the second curve. That would be taking away the white bit from the entire area. That's just going to give me the pink part. And I need to do this between the coordinates a and b, which are 0 and 1.36. The integral of fx is my first answer from part C, my integral of gx is my second answer from part C, so I need to plug in the limits of my 2 points. If I do this on a calculator, this gives me 3.11 plus 2/3 minus 1.09 plus 0, and if I work that out, that is 2.69, which is 2.7 to 2 significant figures. Part E is very similar to find the area of R2. The difference this time is that I'm doing the area under the curve gx take away the area under the curve fx. This has the effect of swapping over my 2 square brackets compared to what I've just done in part D. I'm also doing it between coordinates C and B this time, so my limits are 2.09 and 1.36. Again, if I just substitute these in a calculator, I get 2.08 minus 1.09 minus 3.51 plus 3.11, and that is equal to 0.59 to 2 significant figures. Finally, the question asks me to find the total area, which is adding up my answers R1 plus R2. That's 2.7 plus 0.59, which is equal to 3.3 to 2 significant figures.